Hello everyone, my name is Shishab Sinha and welcome to this video. In the previous lectures we have learned about the arrays and the linked list in linear data structure. Now let's continue with the stacks part. A stack is a linear data structure that follows the LIFO, last in first served principle, that allows operations like insertion and deletion from one end of the stack. That is, top stacks can be implemented with the help of contiguous memory, an array, and non-contiguous memory, a linked list. Real-life examples of stacks are piles of books and deck of cards, piles of money, and many more. As we can see in the diagram, that this diagram represents the real-life example of a stack where the operations are performed from one end only, like the insertion and the removal of a new books from the top of the stack. It implies that the insertion and deletion in the stack can be done only from the top of the stack, and we can access only the stack's top at any given time. So there are two main operations in the stack, that is push and pop. And push is operation to insert a new element in the stack, and the pop is to operation or remove or delete elements from the stack, as we can see in the diagram. Under some applications of stack are, the stack is used as a temporary storage structure for recursive operations. It can be also utilized as auxiliary storage structure for function calls, nested operations, and deferred postpone functions. We can manage function calls using stacks. Stacks are also utilized to evaluate the arithmetic expression in different programming languages, and it is also helpful in converting infix expressions to postfix expressions, which we will see later. And stacks allows us to check the expression syntax in the programming environment. We can match parentheses using stacks. Stack can be used to reverse a string. Stacks are helpful in solving problems based on backtracking. We can use stacks in depth first search, in graph and tree traversal. Stacks are also used in operating system functions. Stacks are also used in undo and redo functions in an edit. Second is queue. Queue is a linear data structure similar to stack with some limitations of the insertion and deletion of the elements. The insertion of an element in a queue is done at one end and the removal is done at another. Queue data structure follows FIFO principle to manipulate the data elements. FIFO means first in, first out. Implementation of queues can be done using array, linked list, or stacks. So this is a basic example of a real life example of queue. So this image illustrates of a movie ticket counter, which can help us to understand the queue where the customer who comes first is always served first. The customer arriving last will undoubtedly be served last. Both ends of the queue are open and can execute different operations. Another example is a food court line where the customer is inserted from the rear end, while the customer is removed at the front end after providing the service they asked for. The following are the main primary operations of the queue, which is enqueue and dequeue. The insertion or addition of some data elements to the queue is called enqueue. The element insertion is always done with the help of the rear pointer. Second is dequeue. Deleting or removing data elements from the queue is termed as dequeue. The deletions of the element is always done with the help of the front pointer. So some application of queues are: queues are generally used in breadth search operations in graphs. Queues are also used in job scheduler operations of operating systems, like a keyboard buffer queue to store the keys pressed by users, and a print buffer queue to store the documents printed by the printer. Third is queues are responsible for CPU scheduling, job scheduling, and disk scheduling. Fourth is priority queues are utilized in file downloading operations in a browser, which means the files which have more priority will be downloaded first. Fifth is queues are also used to transfer data between peripheral devices and the CPU. Finally, the fifth point is queues are also responsible for handling interrupts generated by the user applications for the CPU. So that's it for today. Thank you. Next, we will learn about the non-linear data structure and their types.